So, as a preparatory to the 2024 Advent of Code, I've been working through some old 2020 Advent of Code problems, um, and attempting to get back in the swing of making videos of them. Um, I did days 1 and 2 yesterday. I'm hoping to do days 3 and 4 today. Um, I haven't looked at these since I did them in 2020, so I'm pretty much approaching afresh. Plus, I've learned a lot since 2020, so a lot's going to be different. So, um, with so I guess this is a map with open space as dots and trees as hash marks, and our puzzle input is such a map, but no doubt larger. These aren't the only trees. The same pattern repeats to the right. I, I'm thinking we have modulo in our future. Uh, so we need to start at the top left corner, which is up here. Oops, I never turned on my annunciator. Hold on. I'm going to do that. This is called Karnak. It's a very useful little program. And what it does is it shows where my mouse is when I tap it, and so the left is the left click. If I do a right click, it'll show me that I right clicked, and of course the right click menu appears. Um, when I do things like Alt Tab, it'll tell me that I did an Alt Tab. I don't need this window anymore. I don't need this window at all. And let's see, where was I? Okay, here, editor code. So we're going to start at this empty square here, and we're going to move in Manhattan style diagonals. So right 3, 1, 2, 3, down 1 would be here. Um, and then we're going to count all the trees we encounter. So on this one, we would get nothing here. That's not a tree. 1, 2, 3, down. That is a tree, so that's one tree so far. 1, 2, 3, down. That's not a tree. 1, 2, 3, down. That's a tree. And I think we're now into the horizontal repetition of the pattern. So we went off the edge of our input to a virtual copy to the right. 1, 2, 3, down another tree. 1, 2, 3, down. Sorry, that's this one. Not another tree. 1, 2, 3, down. 1, 2, 3, down. 1, 2, 3, down. 1, 2, 3, down. 1, 2, 3, down until we go off the bottom. Uh, so I didn't see this. So here they marked them all. So we started here. We went 1, 2, 3, down, and so they're showing which ones we ended up at. And X meant we hit a tree, and O meant we hit a dot. So in this example, if you count up the X's, it's 1, 2, 3, 4, 5, 6. Oops, 1, 2, 3, 4, 5, 6, 7. So we have 7 trees. And so the question is, how many trees would we encounter? So we need our puzzle input, which is a much bigger one of these. Yes, much bigger. And again, it repeats to the right. And so, okay. So we need an Emacs. And in our Emacs, we need to start up aoca 2020 03.el. And then we're going to do aoca 2020 3t to insert our little template. We're going to go back to this is in fact our real input, which goes up here at the top. And then this is our sample input, which we do testing on. It's interesting that okay, not quite sure why it highlights extra, so that's going to be our sample. Is there really a blank line there? No. The highlighting was strange because act made it blue on everything but the last line, um, giving you the impression there might be a space. There is a space there. Why is there a space there? No, there isn't a space there. That's where the new line is. Will be. Yeah. Okay. Anyway, it's a little confusing, the highlighting. So X eval buffer. We're evaluating the whole buffer that defines our two def vars with our inputs. It does, in fact, also do this require and set debug on quit. I typed the wrong thing. Uh, one of the things that debug on quit does is that when you type just Control G when you're in the middle of a command, it ignores it. But if you were in the middle of doing something else, then you go into the debugger, and just continuing will go to the normal quit action. You can also quit out of being in the debugger, and that's usually the same thing, but not always the same thing. Um, so we have to count trees. Now, with this type of grid thing, I try very hard to not have to parse or rearrange or redistribute the thing. So I'm going to basically do array references into the string so that an XY reference of 0, 0 will get us there. And in order to do that, I need a bunch of pieces of information. So I'm going to say loop, no, not in caps lock, loop with. Um, so the first thing I need is the X size of the array, which I'm going to call the width. And one way to find that is to search for a new line in the string. So the first new line we're going to get is off the end of the first line. And in Emacs, you can do a string like this that says, here's a new line, input string. And that's going to give us the width of our array that we're doing XY indices into. And the index will go from 0 to 1 minus the width, as usual. We also need the height we can say and height equals, and that's going to be the size modulo modulo the stride. So there's two different things. There's the limit on the x value that we can give, which is the width of the array, which, as I said, that goes from 0 to 1 minus this number w. But there's also the number of bytes we have to move past to go past to the next y location, and that's called the stride, or I call it the stride, and that's one greater than that number. So because it includes the new line, so I'm going to say s equals 1 plus w, and h, which is, sorry, no, x width, yes, width and height equals, this is how many lines high. So in this particular sample example is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's an 11 wide and 10 high rectangle. So the 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 height should be the floor. So we might as well also have the length of the string. So type the wrong thing. Width L equals length of input string mod L stride, I believe. No, not mod, floor. In other words, how many times the strides fits into the length is going to be um, the number high. And we'll in fact test that. Do debug format uh, L equals S S equals. So format takes arguments for the so we want L W H S. Great. So we finished our loop. It's not going to do very much. It's going to loop forever doing debug statements. But you can go to the end of the expression, evaluate it. Now, one thing that I do when I'm debugging these Advent coded things is I'll put the location of the test that I'm working on into a register. So Control XR is the prefix for all the register commands. Space says save the current pointer position, and you tell it which register you want. So I'm going to use A. And then no matter where I am, if I go to the beginning of the buffer, and I can say Control XR jump to A, and that puts me there. So now I can try Control X, Control E to evaluate the expression in front of the point. And that says W is a void variable. 1 plus W. Where's 1 plus W? Ah, my mistake. I don't want and here, I want with. And does them in parallel. Um, so at the point of the and, W wasn't defined. If I do successive with clauses, they're serial. Uh, right. Nope. I need S here too, so this also has to be a with. Let's try that again. Control meta E to go to the end, Control X, Control E to evaluate, Control X RJA to go there, Control X, Control E to evaluate that. And we see that our length is 131. the width and height are in fact 11 and 10, as we said, and the stride is 12. So the way we understand that, and I'm going to just abort out of the debugger. The way you understand that is that if I'm here and I want to go to the next y, if I say uh, 12, sorry, 12, Control F, I have now gone to the next line because I've gone past the 11 characters that are on the line plus the new line afterwards. So we're good so far. This type of debug statement is often useful, so I just comment them out, except that I can't, yeah, so I need the closing parameter. Okay, so I think we're pretty much good. Well, so we need to start out with a starting position, and they told us 0, 0. So with start equals list of 0, 0, and they're telling us that the increment was list of 3x, 1y. So we're going to start with 0, 0, and each time through the loop we're going to go. And so we're going to have, each time through the loop, we're going to have a current position for here equals start, then next. We haven't defined next yet, but that's okay because the first time we need start as the value of here, and then only the second time do we have to have next. So that means now we can do for next equals the list of plus first of here, first of increment, I'm going to use query replace first, second, so we get the second one. So we started out at 0, 0, we're going to increment by 3, 1, so next should have 3, 1, and then the next should be 6, 2, etc. So we can do the destructuring equals here, while less than, yes, while less than here, y height. So as long as we're still on the um, vertical part of the map, then the last thing we have to compute is for index equals. So this is the array reference into the string for the actual place we're on, and this is where the modular comes in, because although we are only going from 0 through height for y, we're going to blow past the width on x. So we have to do plus mod here x width. So that means that if we're past the width, we're going to basically wrap around and use the thing that's inside the first vertical column. And then we need now the offset for the delta. When if 0p here y, it's just 0 for getting to the y offset. Otherwise, it's times the stride 1 minus here y, because we want to skip one fewer than the y dimension that we're on. That'll get us at the beginning of the line that's for that y index. Um, so for entry equals aref input string index. What we can do is we can just let's for the moment just collect entry. So here we are. So we see that we get if you type into Emacs just the number 46, it prints it out as the number, but it also tells you the character. So 46 is a dot. Sorry. And 35 is a sharp sign. So the 35s are the trees. So we can just sort of counting trees. Sum, no, count equal entry aref. So if the entry is the same as the character, uh, so we get 3, that's equal entry. That's wrong. Okay. Another nice keystroke is meta backslash, which deletes white space, and then you can use tab to indent. Um, so what we want in addition to all of these, which we saw before, we want x, y equals index equals and char equals. So those we put at the beginning. So in front of all of these guys, we have to do here x, here y, index, and entry. Oh, I would, I didn't neglect to keep the space. So we are here with 0, 0. The index is 0, 2e. Oh, I typed the wrong thing. I don't want x. So character is dot. Um, I didn't mean to do that. So now we're at 3, 1. The index is 3, and that's wrong. Because we should be on the second line, which means the index should be 13 plus 3. So why are we got that wrong? Control 0, Control L brings this line to the top so we can see all of it. It's short enough that it was shown all there anyway. Index mod here xw. So that brings it back into the 0 through 1 minus w range. If here y is 0, we should print next too. Maybe we're not computing next correctly. Let's do next here. Next is 3, 1. That's good. Next is 6, 2. That's good, but the index is still wrong. So let's go. Now, one of the things you can do in the debugger, I'm going to look at it again. So here we are. We're good. 0, 0 does get the index 0, 0. I'm just going to step through it. I type D. What that does is it does two things. One is it enters the debugger at the next call to a new stack frame, which in interpreted Lisp is pretty much every call. And then it also that marks that stack frame for going back into the debugger when you exit that frame. So we're setting this internal variable dash dash cl dash var dash dash. Now those are uninterned variables, which means I can't type them. They were generated by the loop macro expansion, which I may talk about in some other video, but not here. Anyway, I'm just going to do D. So here, um, right. So that's the variable that's deciding whether it's first time. So we said here, remember, we said it first to start and then to next. So here we are. Um, that's our end test. So here y is index. So here we are. This is where we're computing the index. So here y is 1, and that's correct. No, sorry, I'm confusing myself. Uh, Here is x and y indices. So those go from 0. So only if it's 0. So this zero test is bogus. Uh, so I'm going to say another cool index is kill backward up list. You have to be on an expression and it basically kills the surrounding. Uh, so let's try that to see if that makes it any better. I think I was trying to fake myself out too hard. Arg's out of range. Ah, that's why I was doing it. I had a vague memory that I needed to check. So when we are doing 0, 1 minus here, y is negative. So in fact, that change is probably correct. I mean, the original thing. I just did undo to put it back. So what we want to do is we want to move back. So if we're on, it isn't 1 minus here, 1 here. This is what I wanted to kill. Uh, just like almost everything in Emacs, if you do a metax command, you have a history. So you can say meta p, get back to the previous one without having to type anything more than that. So let's try that. Uh, so here, index 0, continue, second one, index 15. Now that's much better. So that means we got the 12 to get us to the next line and then added 3 to get to 15. So okay, so now we can just step through them. There's only 10 of them. And why did we get back nil? Oh, because we're not collecting or counting anything. We got rid of that somehow. Count equal entry aref. So that aref is saying just give me the character that's the first character of that string because we have a character, not a string in entry. Um, and we're just going to compare that. So inside this loop, what we're going to do is we're going to just count how many trees we saw. Uh, so we're going to still continue there. And we are seeing many trees. 6, that's wrong. It said 7. So we're getting too big for this. So we think the maximum height that we can get is 10. Is that in fact right? So we would never want to have a index of 10. So I'm going to continue. Maybe we're looping, exiting the loop early. So so the next is 18.6. So now we're here is 18.6. The next is 21.7, 8. Next is 27.9. We never did 30.10. 3010 should be okay. Right. And now we get 7. So the problem is we basically skipped the last one. So we can comment out this debug line, recompile. Oops. My keys aren't on the home row, and in this office, the auto lights have turned off, so it's hard to see what I'm typing. I'm a touch typist and usually don't look. I must have typed F. Not in most necessary command loop. Emacs. Don't know what I typed. To get into this, we can do Control H L. Abort mini buffers. I do want to abort mini. Find file read only. So I did a Control X, Control R. That will, no. Yes, Control X R is what uses registers, and I used Control R instead. That's how I got there. Uh, so this is annoying. Control G is supposed to interrupt and get me into the debugger, but it's not doing it. Presumably because they've rebound debug on quit to nil. Uh, uh, it doesn't tell you how to abort. Abort mini buffers. import the current mini buffer. If we're not currently in the innermost mini buffer, prompt the user to confirm the aborting. It's it's not doing what the documentation says it should do. We're not currently in the innermost mini buffer. It's supposed to prompt to confirm the aborting. So, oh. So going into debugger by itself, that didn't work. So each time I type D, it's going to do some more of its existing processing. Here's going to run a timer. Okay, well, lovely. Yes, I will have to redo this video. That will teach me for using a newer Emacs. Not even that new. Okay. aoca 2020 A03. No day. And in fact, there probably was a change. I don't know that it's relevant. Um, when it says this MetaX recover this file, it's often useful to know beforehand what it is that was being recovered. So the easiest way to do that is to say Control X, Control F, the same file name, which you can get by just doing meta n, sorry, yeah, meta n, but then appending and prepending sharp signs, as you know, and that's the saved file that it's keeping that it had auto saved, and now we could do medx compare windows. Uh, right, so this had the change that was moving the while to the end, which is a useful change. So in fact, I do want to say medx recover this file. We can go down here, make sure that's the only change. Medx compare, just meta p, and there's the other changes uncommenting this debug statement, and you can say u medx control u medx compare windows. Whoops, I did not mean to do that. Control u medx compare windows. That says ignore white space, and so now we're at where the while got moved to, and directly above the parentheses. So I do say meta, sorry, Control G, medx recover this. I didn't want to do that either. I just want to kill this buffer. So now we've got the change. We can say medx eval buffer. So it gives us the 7, which is the right answer on this part. So let's see what it gives us on this part. 294. Actually, let me do because I like to include the things. I often want to have a keyboard macro. So if I'm on the line where the test is, I can define a keyboard macro that searches for the close paren, and then does a minus meta control shift at to mark it, meta W to put it on the kill ring, control E to go to the end of the line, then control U meta colon, yank that back in to actually evaluate it and put the answer on the line. Um, this macro could be more elaborate. It could notice that you had a wrong answer and erase that. Um, I have sometimes done that in the past, but we'll test it out. I'm on this line, uh, but it assumes I was at the beginning. So I should have gone to the beginning of the line. So that's got me my 294, and I put it into the buffer. So we'll save that buffer, and we'll see if that's the right answer. It is, in fact, the right answer. So Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop, after all. Then determine the number of trees you would encounter if for each of the following slopes you start at the top left corner and traverse the map all the way to the bottom. Okay, so they're just giving us different slopes. So 1, 1, 3, 1, 5, 1, 7, 1, 1, 2 are the delta x, delta y's, and 3, 1 is the one we already did. So, and in the example sample data, the answer would be 2, 7, 3, 4, 2 trees on those. And they want you to multiply them all together to get the right answer because they only want one answer. So again, I'm going to, well, first of all, I'm going to clean up this guy a little bit. Get rid of this white space and this white space. I'm going to uh, make it slightly less. Okay, well, that's all the cleanup I'll do. So I'm going to copy it again. So we're going to redefine it, but the old copy is there first. So if you loaded this file or evaluated buffer, first you define the old one, and then you'd redefine it with the changes. But that's so that we can see what we changed. And really, the only thing we want to do is we want to call this function with different slopes. We baked the slope in here as this. So we can put in an optional argument. Optional argument of requested slope. And here we can say or requested slope or 3-1, which is the default if you didn't specify it. So if you just call it without the optional argument, you get exactly the same behavior we had before. And then for part 2, what we have to do is we have to actually call it with all the slopes. Let counts loop, loop with slopes equals, now what slopes did they say? 1, 1, 1, 3, 5, 7 ones. 1, 3, 5, 7. And then 1, 2 at the end. 1, no, 1, 1, 3, 1, 5. Yep. So different keyboard macro. So I don't want to start there. Didn't want to type the Control C. So here I am on the first number. I want to make it a list of that number 1. And then I want to go forward and back to be at the position of the next number. And then we want to go 4 back, list 1, 3, 5, 7. The last one was 2, 1. Right, I think. No, 1, 2. Meta T will transpose words. Control meta T would transpose whole expressions. Either one in this case would be the same because each expression was a word. So here's our list of slopes that we want. For slope in slopes, collect aoca 2020-03 part 1 of uh, part 1 of input string slope. This is now the extra uh, thing into trees. Fun. So I could spell trees better. Uh, apply, multiply, wherever multiply is, to trees. So that we have to return it. So, you can try it on this guy. Oops, we never redefined our one where we added the optional argument. So complained that there was an extra argument. Uh, ah, it wasn't that. It was that we have a part one. We don't have a part two sample. So my template. So 336 is what it says the answer is. Is 336. That is in fact what the sample is supposed to get. So I can redo my. So now let's try this one. Whoa, a biggie. Let's try that. Indeed, that is correct answer. So older versions of Emacs didn't have big nums, but they did have the calc package. So when I was doing this, probably in 2020, I wouldn't have gotten the right answer by doing this. Um, the But not only can you use the calc package, but you can also basically do shell commands. So you could just generate the shell command to invoke BC to multiply all the numbers together and get back the answer as a string. Anyway, that's day 3 with some exciting detours along the way.